Hello, hello. Welcome to Math with Ruth. So today we will be talking about number theory and integers. There has been a putting together of several problems, and I, your trusty teacher or whatever, will be helping you work it. Okay, enough of the goofing around. Let's get down to business, and I will start this thing off. So let's see. Sorry about that. Alrighty. So, Written Exam 3 by Ruth Suarez. So the first problem we see is this problem right here. And I know it's a lot of words and it's kind of confusing, but it says, use divisibility test to decide which of the numbers 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is the divisor of the numbers in the left column of the following table. Write yes or no for each number, then explain why. So let me see if I can zoom this in. Oh my goodness. All right, so I'm just going to be kind of reading to you what it says. So on number 2, is 2 divisible by 684? I put yes. Number ends in even digit. Then we move on to the next number. Is 2 divisible by 2064? 2064. Yes, the number ends in an even digit. Then is 2, so as you can see, we're going down the line like this. So is 2 divisible by this? Yes, yes. No, no, because the number doesn't end in an even digit. So no, because it ends in 1. The next one, yes, because the number ends in 0. So pretty much the number for it to be divisible by 2 has to be, the last number has to be 2, 4, 6, 8, 10, or 0. Well, not 10 because then, it's 2 numbers. So the last number has to be those numbers and 0. So the next one is this number end in an even or a 0? And yes, it does because it ends in 0. So that is a yes. Now, is 2 divisible by this number? As you can see, you only have to check the last number. So is this 2, 4, 6, or 8? Yes, it is. Therefore, it is divisible by it. Now, we move to 3. So what we need to know is, what is the rule of 3? Well, as you can see, you have to add it together. You have to add the whole number together, and whatever the sum is, if it's divided into 3, then yes, it's correct. So the first one, as you can see, we add these together, which gives us 18. And is 8 divided into 3? Yes, it is, because 3 times 6 is 18. So therefore, yes, that is correct. Is 2063 divisible by 3? And we added yes. And why is that? Because the number added together fits into 3. Then we move on to 51051. Is it divisible by 3? Yes. Added together, it divides into 3. I'm not going to go exactly for it because it is a lot. So pretty much this one is yes. And this one right here is yes as well, because whenever you add all these numbers together, it divides into 3. Then we move on to this number. Is this divisible by 3? No, because whenever you add it together, it doesn't divide into 3. So therefore it's no. Now the last one. Is it divisible by 3? Yes, because added together, it divides into 3. So as you can see, I'm just going to go for one, and hopefully you can see why the number that we got is the number that we got, if it's divisible or not. All right, so now we move on to 4, and it's asking us, since the divisibility rule of 4, if the last 2 digits form a number divisible by 4, then yes. So we have to be looking at the last 2 numbers. So is this number right here, 84, divided into 4? And it is. So therefore, it's yes. So now we look at 64. So is 4, can it divide, does 64 divide into 4? And yes, of course it can. So therefore, because whenever you divide, you say 64 divided by 4, it's going to give you 16. So therefore, yes, you can. Now we move on to 51. Can you divide this number by 4? And no. So therefore, you can't. So therefore, you don't. Now 90. Is it divisible by, can you divide 4? Can you divide it into 4? And no, you cannot. Well, then we move on to this one. Can you divide 40 into 4? Yes, you can, 10 times. So therefore, it is divisible by 4. Now we move to the 28. Can you divide 28 into 4? Yes, you can, because 28 divided by 4 is 7. Now we move on to the divisibility rule of 5, which is anything that ends in 5 or 0. So, is this divisible by 5? Does it end in 5 or 0? No, it ends in 4. We see here, nope, it ends in 4, not 5 or 0, so no. This one is no as well. This one is a yes because it ends in 0. This one is also a yes because it ends in 0. And this one here is a no because it ends in 8. So it's pretty simple. I really like 5s because you can just look at the last number. Now 6. What is the divisibility rule of 6? It says if the number is divisible by both 2 and 3. So if it's not divisible by 2, but it is by 3, it's no for 6. If it's divisible by 3 and not 2, it's still no. If it's divisible by 2 and 3, then that's a yes. So now, all we have to do here, it's like super simple. So what we have to look is at these. Is this number divisible by 2 and 3? And we see, yes, both of them are. So therefore, this is also a yes. Now, is 2064 divisible by 6? Is it divisible by 2 and 3? We see yes, and we see yes. So therefore, yes, it is. Now, is 51051 divisible by 6? Is it divisible by 2 and 3? No, it's not divisible by 2, but it is divisible by 3. But we have to have both of them, so therefore, that's a hard no. Now, is this number divisible by both 2 and 3? And we see yes, and we see yes. So therefore, 6 is divisible into that number. Now, is this one divisible? Let's see. Is it divisible by 2? Yes. Is it divisible by 3? No. So therefore, we have to be that good friend and only be friends with the ones that that are by both of them. You know, because you can't have one and then not the other. So therefore, 6 is a nice friend to 2 and 3, and it wants it to be both divisible, you know. So therefore, no. Now, is 2 and 3 divisible by this number? Yes. And yes, therefore, 6 is divisible by it. That means it can be friends with it. So that's a nice way of putting it. Now, what is 7? Let's see. You have to add... so you have to add these two numbers to the last one, but you have to double this number. But you have to subtract it. So 68 minus, what is 4 plus 4? It's 8. So it's 68 minus 8, which is going to give you 60. So 60 does not divide into 7. So therefore, that's a no. You go on to these, which you already saw the process. So no, then yes, because 50 minus 8 is 42, and 42 divided by 7 is 6. Or divided by 6 is going to give you 7, so therefore it is, right? This one is also yes, because all these numbers, you have to keep going at it. It's a pretty long process, so let's just look at it. 6, the last of them was 6 minus 6 is 0. So if it's going to give you 0, then yes, it's divisible by it. Let's see, why is this one a no? Because the last of those were 25 and doubled, which I'm guessing was a 1. So it's 25 minus 2, which is going to give you 23. It isn't divisible by 7. No, because the last of them was 50 minus 2, which is 48. That is not divisible by 7. Let's see. Alrighty, so now we move on to 8. The last digit not divisible by 8. Because why? Why is it? What is the divisibility rule of 8? I'm sorry. The last 3 digits are not divisible by 8. So 684 is not divisible by 8. So let's look at the last 3 digits of this one, which would be 064. So the last 3 digits are 64. So can 64 be divided into 8? Yes. Yes, it can. Which is going to give you 8, because 8 times 8 is 64. So yes. Now this one is 51. We already know right off the bat that that does not fit into 8. So that's a no. No, because 490 is not divisible by 8. So therefore, that number is not divisible by 8. No, because the last 3 digits are not divisible by 8. 740 cannot be divided into 8 evenly. So therefore, that is a no. 528, is it? Yes, because 528 divided by 8 is going to give you 66. So therefore, it is divisible. Now, 9. Sorry, my mouth is getting really dry by talking so much. The sum of the digits is 18. So 18 divided by 2 is going to give you 2. So it does divide evenly into it. Therefore, it is right. It is divisible. So you have to add all of these together and then divide it by 9 and see if it gives you the number. So it doesn't, because it has a remainder. Therefore, you can't do it. You know, you have to add it, and then the remainder of it has to be divided into 9. And if it gives you a remainder, then it's not divisible. So as you can see, this number added together, then divided by 9, does not divide evenly. Therefore, it is not divisible by 9. However, this number right here, added together, then divided by 9, so I guess all of it together, 6 plus 4 plus 4 plus 4 plus 9 plus 0 is going to give you 27. 27 divided by 9 is going to give you 3. Therefore, it divides evenly, making it divisible by 9. Now, this one is a no, because you already know that the sum of the digits is 32, and 32 divided by 9 has a remainder. Therefore, it is not divisible by 9. The last one, the sum of the digits is 27. 27 divided by 9 is divided evenly into 3. Therefore, it is divisible. Now, let's see if 10. What is the rule of 10? The rule of 10 states that the only reason a number can be divisible by 10 is if the last digit is 0. So this is quite simple, actually, because you don't have to be stressing out about adding numbers and then dividing it, you know, because you can now just look at the last number. Is this 0? Nope. So therefore, it is not divisible. Is this 0? No. So then no. This one's not 0 either. So therefore, it's no. This one is a yes, because the last number is a 0. This one is also a yes, because the last number is a 0. And this one is a no, because 8 is not a 0. So therefore, you can see down here, it's no, 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 yes, yes, and no. Now, we have 11. What is 11? So what you do here is you add all the even numbers and then you subtract it by the addition of the odd numbers. So right here, since we only have 3 numbers, we add 6 and 4. And then this one stays by itself. So 6 plus 4 is 10. Minus 8 is going to give you 2. So can 2 be divided into 11? Nope, it cannot. Now we do the same thing for this one. We add 2 plus 6, and then 4 plus 0. So it's 2 plus 6, which is going to give you 8, minus 4 is going to give you 4. Is 4 fit into 11 evenly? No, it does not. Now, this one right here, we add 5 plus 0 plus 1, which is going to give you 6. And then 1 plus 5 is also 6. So 6 minus 6 is going to give you 0. So if it's 0, then it is divisible. Now, as you can see right here, for number, this humongous number right here, we add 6 plus 4 plus 9. And then we add 4 plus 4 plus 0. So let's see. It is yes, because 6 plus 4 plus 9 is going to be 19, minus 8 is going to be 11. So 11 does fit into 11, so therefore it is a yes. And this one's a yes because 2 plus 7 is 16, minus 16 is 0. So therefore it is a yes. And no, the last one is no, because 5 plus 2 plus 0 plus 2, and then minus 0 plus 5 plus 5 plus 8. Let's see. It's 9 minus 18, and that is going to give you a negative 9, so it is not divisible. And that, my friends, is why we got that answer. So as you can see right here, these are the divisibility rules, and hope that is very helpful for you guys. Now, number 2. What does number 2 say? It says, use the process of 9 to check each of the following answers. So as you can see, we have an addition problem here. So it's going to be 416 plus 7,490 plus 69,844 equals 112,790. Now, how can we check this? As you can see here, we replace every number in the calculation by its remainder when divided by 9. Based on the divisibility test for 9s, the remainder for the sum of the digits is the same as the remainder of the original number. First, we start with the first number, which is 416. Calculate the sum of its digits. So we use that number as though it is next to each other to add. So we add 4 plus 1 plus 6, which is 11. When divided by 9, it has a remainder of 2. Then we continue with this process for all the numbers in the sum, which the next number, as we can see, is 7,490. So we add all those numbers together. So 7 plus 4 plus 9 plus 0 is 20. So 20 divided by 9 has a remainder of 2. Now we go to the last one, which is 69,844. So we add all those numbers together. And as you can see right here, and this one, let's see, oh, my bad. And that number right here, it has a remainder of 30, the sum is 31. When divided by 9, it has a remainder of 4. Therefore, the next thing we do, the sum of the digits of the answer, which we saw up here in the top. So this number right here, we do the same thing. We add them all together. So the digits of 112,790 is 20, which has a remainder of 2 when divided by 9. And then, as you can see, we put all these numbers, all the remainders together for the 3 numbers that we got. And then we add them together, and it gives us 8, which has a remainder of 8 when divided by 9. So as you can see, these 2 numbers are not the same. So based on the casting out of 9, there is an error in the calculation. As you can see, because right here, oh my goodness, it keeps moving. So right here, we place every number, as you can see, right, where is it? It's 2. So you can see that's why we got those numbers 2. Then we add them all together and it has a remainder of 2. So therefore 2 and let me see. Wait a minute. So since the remainder of all these numbers together is 2, and then the sum gives 8, which has a remainder of 8, so these two numbers are not the same, so therefore that makes it have a error in the calculation. So the correct sum, as you can see, the answer that we got was wrong. So the whole point is that these did not have the same answer. So therefore that one's wrong. So now, as you can see, the correct answer would be 416 plus 7,490 plus 69,844 equals 77,750. That is the correct answer. Before we had 112,790. That was way above. So that is how we will be working out. That is how you do that. And as you can see right here, use the same process to check the calculation by finding the remainder for the given number. The remainder of this number, as you can see right here, is divided by 9 and is 8. So keep this in mind right here. So therefore we add these together, and then we divide it by 9, and the remainder is 0. So I guess it divides evenly, so we put 0 right here. Then we add all these together, we divide it by 9, and it gives us a remainder of 3, and that's what we put right here. Now we add all these together, and we divide it by 9, and it gives us a remainder of 5. And then we do the same thing. We add this together, then we divide it by 9, and it gives us 8. So now what we have to do is we have to evaluate the casting out 9's calculation and find its remainder. The sum of this, which is right here, which is 0 plus 3 plus 5 plus 9, gives us 16, which divided has a remainder of 7 when divided by 9. So is this number and this number the same? No. Therefore, that is how we know that it has the wrong calculation. So this plus this plus this plus this does not equal 23,892. The correct answer is this plus this plus this plus this actually gives us 23,992. Now, how do we use the casting out 9's for subtraction? Which is the same process to check the calculation. We begin by finding the remainder of the given answer. So it's almost the same thing, except we subtract. You see right here, the addition of this divided by 9 is going to give us 8. And the addition of this divided by 9 is going to give us 2. So instead of adding them, we just subtract them. So then we evaluate the casting out 9's calculation and find its remainder. The sum of 8 minus 2 gives us 6, which has a remainder of 6 when divided by 9, because 6 cannot be divided evenly into 9. So therefore, it just stays the same. Based on the casting out of 9's, we see that this minus this does not equal the other number we had. So this minus this, it's actually going to give us 74,688. Now, how do we do multiplication? As you can see right here, we use the same process to check the calculation. Begin by finding the remainder for the given answer. The remainder of this number divided by 9 is going to give us this. So when it says the remainder, it's going to be all of these added together, and then the sum of that divided by 9 And then 9 divided by that is going to have a remainder of 6. So remember this number right here. Then replace each number in the calculation with its remainder when divided by 9. So it's going to be this times this becomes 4 plus 8, because we add 3 plus 3, which is 6, plus 7, which is going to give us 12, I think. Yeah. And then it's going to be divided by 9, which is going to give us 4, a remainder of 4. Then it's going to be 6 plus 2, which is going to give me 8 divided by 9, which it cannot be divided by that, so therefore it just stays the same. And then we evaluate the casting out of 9s calculation. The product of 4 times 6 gives us 32, which has a remainder of 5 and divided by 9. So 5 and 6 is not the same number, so therefore we see that that answer is incorrect. So the correct answer is 337 times 620 is actually 208,940. Now, moving on to number 3. This is actually a little bit more, a lot more words, definitely. So, what can we see here? The number 1 is the colored rods shown here are 1 centimeter squared, and of length is 1 centimeter, 2 centimeters, 3 centimeters, and it goes all the way to 10 centimeters. We say that a rod measures another rod if a n number of the first rod placed end to end are the same length as the given rod. A. We see all the rods that could be used to measure the 9 rod. So what can we use? We choose these by looking for the factors of 9. So the factors of 9 are what can be multiplied together to give us 9. So we have 1, 3, and 9. So that's going to be our answer, because 1 times 9 is going to be 9. 3 times 3 is going to be 9. And 9 times 1 is 9. So that is going to be our first answer. Our second answer is we look for the factors of 6 and decide that 1, 2, and 3, and 6 would measure the 6th rod. And why is that? Because of the same thing. We are looking for the factors of 6, which is 1, 2, 3, and 6, because 1 times 6 is 6. 2 times 3 is 6. And then 6 times 1 is 6. So we can mix and match, and we would get 6 by looking at that. So we are trying to find and see the biggest number they both share, which is the greatest common divisor. So what is the greatest common divisor of 6 and 9? So we see that 6 has 1, 2, 3, and 6, and 9 has 1, 3, and 9. So as we can see right here, they share, how many numbers do they share? So they share 1 and 1. Do they share 2? No, they do not. Do they share 3? Yes. Do they share 6? No. Do they share 9? No. So therefore, 3 is the biggest number they both share, and it is making 3 the greatest common divisor of 9 and 6. So how would we explain this to a group of children? So we grab a 10 rod and an 8 rod to form an 18th train. You show all the rods or trains will measure the 18th train. You look for all the factors that multiply together will give you 18. Factors are 1, 2, 3, 6, 9, and 18. And why is that? Because all these numbers mix or match. So 1 times 18 is going to give us 18. 2 times 9 is going to give us 18. 3 times 6 is going to give us 18. So therefore, these are the numbers that you can use these are the sizes of the rods that you can use to find 18. like I previously stated, we can use the factors of 18 to create an 18 train using measurements we would use. So instead of just saying 1 rod, 2 rod, 3 rod, it is going to be 1 centimeter, 2 centimeters, 3 centimeters, 6 centimeters, 9 centimeters, and 18 centimeters. That is how we can measure. That is the sizes of the rods that we can use to measure this 18 centimeter train. And this is just me explaining how we can use the color rods to demonstrate the notion of greatest common divisor to children. And it's by grabbing an 18 train, then all the rods that could measure the 18 train, then grabbing a 12 train, then all the rods that could measure the 12 train, which would be, as we said previously, that the numbers would be 1, 2, 3, 4, and 6, I think, and 12. That would be in the same. And the 18 would be 1, 2, 3, 6, 9, and 18. So now you would ask them all the rods that 12 and 18 shared. Finally, you would ask between the rods they share, which is the largest one. This would result in them choosing 6 because 6 is both shared in the factors of 12 and 18. So that is the answer for that number. Now, we are going to be using the table method to find the least common multiples in parts A through C in prime power forms. So now we have, see this little table right here. That is how we will be doing what we are doing. So this is just kind of like an example. So the least common multiple of 48, 25, and 65 in prime powered form. Begin by constructing the first row of the table. So we put 48, 25, and 65. So now we say, what primes divide the number evenly? So I chose to put 2 because 2 divided by 48 is going to give me 24. Then we just bring down 25 and 65 because we can't divide it evenly. We can divide it 2 even and get an even answer. So then I choose 2 again because I have 24. So 24 divided by 2 is going to be 12. And then again, I can't use 2, so I just bring these down. Then I have 6 here, and it's going to be 12 divided by 2 is 6. Then it goes down again. Then we have 6. Then 2 divided by 6 is going to be 3. We can't divide it, so we just bring these down. Then we change it up to 3 because we have a 3 right here. So then we divide 3 by 3 is going to give you 1. And then you can't divide these. So we just put those down again. Then we switch it up to 5. And we just go up from there. So 5, you already have 1, so you don't divide it by that. So you divide it by 25, which is going to give you 5. And we just bring down the 65 because it's too big still. So then we use 5 divided by 5 is going to give you 1. And then 65, it's by itself. Then 5 divided by 65 is 13. You bring down the numbers that do not contain the factor 2 down to the next line. Continue the process with 2, 3, and 5. So the answer would essentially be, with using the process, the answer would be 2 to the 4th power times 3 to the 1 power times 5 to the 3rd power times 13 to the 1st power, because we only have 4 2s and 1 3 and 3 5s and 1 13. So that is going to be our answer. We do the same process for this one. As you can see, we divide this by this. It's just 20. We start with 2 until we can't divide it anymore by 2. Then we switch to 3. And then we switch to 5. And then it's going to give us 11. So the answer would be 2. We have 3 2s and 1 3 and 1 5 and 2 11s. So that's going to be the answer. We do the same one here. I just don't want to continue that because it's going to be a very long process, as you can see right here. I'll let you check and see these numbers right here and why. We start with 2, we switch up to 5, and that is how we divide each and every single one so that we don't have any even numbers, and we all can just get that 2 has 2 2s, and there's 3 5s, there's 1 7, and there's 1 11. And that is the answer. So then the next one is number 5. It says, in a machine, a gear with 48 teeth is engaged with a gear with 84 teeth, with teeth A and B on the small and large gears, respectively. In contact, as shown, how many more revolutions will the same gear have to make before A and B are again in the same position? So, what do we do here? Well, I wish I could have drawn you an example, but I did not do it and I forgot. So I am sorry, I will show you something better. So right here, you kind of have a visual, and that is what essentially we're looking at. So the machine, a gear with 48 teeth, as you can see right here, has 48 teeth, is engaged with a gear with 84 teeth, with teeth A and B on the small and large gears, respectively, in contact as shown. How many more revolutions will the small gear have to make before A and B are again in the same position? So, let me show you something else. I'm sorry about that. Okay, so the first step is to find the largest common multiple of 48 and 84, and find the product of the prime powers in the prime power factorization of 48 and 84 that have the larger exponents. So we write the prime factorizations of 48 and 84, which 48 is going to be 4 2s times 1 3, and 84 is going to be 2 2s, 1 3, and 1 7. So that's good to know. Keep that in mind. So we find the least common multiple of these two. So we choose the biggest ones that they have. So as you can see in this one, there was, in 48, there was 4 2s. So we choose that. Then we choose the 3 and the 7. So we combine those two together to give us the answer, 336. We then divide the least common multiple by the number of teeth in the small gear. So we put 336 over 48, which is technically dividing them, and it's going to be 7. Therefore, the small gear has to make 7 more revolutions before A and B are again in the same position. And that is going to be, your answer is going to be 7 more. Now, we are coming to the end. It just says, make a magic square using the integers -7, -6, -5, -4, -3, -2, -1, 0, and 1. So the purpose of the magic square is to arrange numbers so that their sum may be the same in all rows, columns, and 2 diagonals. So let me show you essentially what it looks like. Sorry for so much movement around here. So oops, sorry about that. So essentially, this is what it's going to look like. You have to make a magic square using integers -7, -6, -5, -4, -3, -2, -1, 0, and 1. So how do we do that? So first, determine the magic sum. So we have to know what sum we're trying to get. So let the magic sum be represented by x. The integers to be used in the square are given. So then you have to find the sum of all the given integers. So not just some, we have to add all of these together, as you will see in my PowerPoint. So it's much easier to just show you. Oh my goodness. Technical difficulties are really fun, but just bear with me. I will show you what I'm talking about. So therefore, we add all of these together. So -7 plus -6 plus -5, -4 plus -3 plus -2 plus -1 plus 0 plus 1 is going to give us -27. It is known that the sum in each row is the same. It was named sum x. 3 times this sum is the same as the total sum of all the integers. So 3x equals -27. So then we divide 3 into -27 into 3. Therefore, the magic sum x is going to be 9. So now we use the magic sum to help complete the magic square. Use a trial and error to figure out where to place the numbers so that each row has a sum of -9. Each column has a sum of -9, and each diagonal has a sum of -9. Sorry, that was supposed to be a column instead of a row, so just ignore that. So what I did here is I just kind of started putting the numbers as I went. So I said, we already had 0 and we had 1. So what I did was, okay, so we had to find the two numbers. So I chose -5 and -4 because added together, it's going to give me -9. But then I said, okay, so I have this sum. So now I have 1 and -4. What would give me -9 in this nice column right here? So remember, I only had 1 and -4. So I said, well, I already have 5, but it would subtract 1 from it. So then I said, what is 1 minus, -4 plus 1 is going to give me -3. So what added by -3 would give me -9? And the answer was -6, because I hadn't used that number before. So therefore, I could use this number. So I came up with -6 because -4 and -6 is going to give me 10. Minus 1 is going to give me -9. So, okay, we have -9 here, -9 here. So now that we have this row and this column filled out, we only have to find these 4 right here. So just try to ignore these for now. So what I did was like, okay, so I have 1 here, right? And it's gonna subtract by whatever number I have. So I still have my other numbers. I still have 7. I still have, well, -7. I still have -3. I still have -2, and I still have -1. So let's see. So then I said, well, you know what? Let's put -3. So -3 is going to essentially equal -2 because you're subtracting 1 from it. So I said, what plus -2 is going to give me -9? So then I said, well, we haven't used 7. So then I just put -7 over here. So we said -7 plus -3 is going to give me 10, -10. And then minus 1 is going to give me -9. So therefore, this whole thing is correct. Then I started looking at these. So I said I have -3, -5. It's going to give me 8. So what number haven't I used? And I realized I hadn't used -1 and -2. So then I said, well, -1's the right answer because -5 plus -3 is 8, -8. And -1 is going to give me -9. And then I had 0 and 7. And I said 7 plus what is going to give me 9? And it was -2. I essentially got lucky because I started in the right direction. But if I wouldn't have, I would have been going around in circles for a long time. But that's the whole point of using trial and error to figure out where to place the numbers. So that is how I did that. Anyway, I hope this helped you guys understand what is going on and that you liked the video. So till next time.